Chapter 8, Robots, Sensors, and Motors. So this tutorial is going to go over a linear distance sensor such as a LIDAR, and also demonstrating another option for viewing camera images all in simulation. So this will solely be from simulation. So from the raw simulation page in the Turtlebot 3 manual, there is a Turtlebot world or a Gazebo world that has basically a standard house. So we'll use this house as a Gazebo world that we're operating in, and we'll still utilize the Turtlebot 3 and then launch 3 files. One, of course, being the Turtlebot 3 house launch. Then we will launch RViz in order to be able to see the laser scans and the image view from the perspective of the robot. And then finally we'll do Turtlebot teleapp keyboard, which will allow us to drive the robot and see the world changing. So it's from this raw simulation tutorial that we'll be leveraging most of our work from. And then of course on LDS and other types of sensors and cameras are found in the textbook chapter 8. So we will be looking at how we're actually visualizing these laser scan values. So we're going to use a 2D LiDAR, so a single scan LiDAR, which is returning and showing up in RViz, which is our visualization tool. And then of course how the robot is utilizing a laser distance center to do SLAM and mapping and other types of tasks, obstacle avoidance and path planning. So we'll launch right into our virtual machine. So once we start it, we can look at the various launch files. So here's my terminal window. I already went ahead and preloaded the Turtlebot 3 Gazebo, Turtlebot house. Down here is RViz, is the RViz launch, and then here is the teleop. So really, again, think of Gazebo as it's a simulation, but it's simulating a real robot. So RViz or Gazebo is giving us our actual image data, or LiDAR data, or odometry, any IMUs, any sensor that's on the robot. Gazebo is going to simulate that sensor data. RViz is going to visualize it. So how does the robot see? How does the robot perceive its environment? And allowing the human to see the robot state and how the robot is interpreting its environment. And then of course teleop is how the human is interacting with the robot. So I'll just go ahead and launch these, and then we'll split the screen so we can see it side by side. So we'll let Gazebo run first and get loaded. And again, this is one of the many Gazebo worlds that's available. This is really just a house. It's starting the robot inside of the structure here. And then we'll run RViz as well. And of course, running an operating system on top of an operating system, and in a tool such as RViz, it can be a little slow. So expect when it's running on your actual machine that it's going to run slow. So here's the house. Here's the actual robot here. The screens are flipped, which is fine. I mean, we're just really looking at the two different images, or the two different tools, right? RViz on the left, Gazebo on the right. So again, think of Gazebo as your the actual robot, and how we're going to be interacting with it. And then RViz is what the actual robot is seeing. So if this is our robot, here's a table and here's some walls. Let's expand RViz briefly and scroll in. So here we can see the robot itself, and then these four dots are actually the legs of the table. Right, a little hard to see. I'll scroll in a little bit more. So these four dots, and then this is the laser scan of the walls. So the robot is picking up these walls. This opening here is a doorway. And again, if we look at our different topics here on the left, right, laser scan is showing up in a red color. Right, now if I were to unclick that box for laser scan, of course it disappears, and I'll click it back, and then we'll get our laser scan again going. So this is a 360-degree LIDAR. It's spinning. It's a single scan, right? So it's two-dimensional, and whatever it is reflecting off of, it's picking up those returns and then giving that back to the sensor, to the processor that is then generating this 2D laser scan. So again, the text goes into much of the theory on how we're actually generating the laser scan, what all these different subtopics mean. Obviously, as you get further away, if you're outside of the effective range of the laser, it's not going to have a return. So then you want to eliminate that as basically noise, and not record that. Again, so the text goes into a lot of this description for the camera. So I'm going to go ahead and enable that. And this is much like the other demo. So there is a physical camera on the robot, and it's expanded. So if we look at the camera topic, we can enable it, and then we are going to want to select the right topic that we're going to look at. So again, it's a little laggy since I'm running all of this on top of my actual machine. But if I go to the image topic and select the correct one, it should show up here down at the bottom. And there it is. So this is, so you see it actually overlays the image view and the laser scan together. So as a robot is facing this wall, and you see this opening. So I'll go ahead and switch into the keyboard teleop mode. So of course we have to select the right box, right? So I'm going to click in this box, and now we can actually give it some velocities, and then you can see the actual robot moving with the image view. And as we're getting closer to this wall, and then I'll turn right slightly and then continue forward. So as we're approaching, actually we don't want to go too far and crash into the wall. So I'm going to go left again, and I'll stop there. So here's the opening, and now if we go back to Gazebo, right, here's our physical our physical robot that we just move slightly forward. Right, here's the table, here's that wall opening, and I'll try and zoom in here slightly. Let's zoom in out. So again, you can look at the tool and play with Gazebo, play with RViz, and look at the different perspectives. Let me go ahead and reset the camera view. So again, a little bit laggy, but not too bad. So again, RViz, camera view, using a LIDAR and a camera.